Good morning, everybody. This problem is actually computationally quite difficult. Now, what I'm going to do right here is write down the least common multiple. Now, this takes some time, but there's 2 to the 4th times 5, and it's easy to see that 2s and 5s are common to a lot of these terms here. What else? What else do we need here? I think times, do we have, yeah, times 7 also. We can see a 7. 7's got to be part of the prime factorization here. 13 right here. And not so clear is 19, which happens to be a factor of this last term. Now, the reason why I'm writing this down, this LCM, sometimes called the least common denominator, also the LCD. I think it's common in U.S. schools, the least common denominator. You could go through and try to simplify each one of these fractions, write them as a denominator that of 138,320. Okay, that's a possibility, but then even if you did all that hard work, you're probably going to have to reduce the fraction, right? So there is a better approach here. Notice there's some structure right here. Notice you can rewrite this as 1 over 4 times 4 plus 3. Okay, that's the form of this. Okay, big deal. Well, but notice that on the very next one, you get 1 over 7 times 7 plus 3. Right, and we'll do just one more. You can see right here, this one is 1 over, what do we get? 10 times 10 plus 3. Now, the others enjoy a representation just like this. And you may say, well, so what? But all of them have a form, all of these fractions have a form that's similar to these 3 concrete examples I've shown you. And so each one of the terms has this form. Okay, each one of these 6 terms, 1, 2, 3, 4, 5, 6 terms, is in this form, 1 over the product n times the quantity n plus 3. Okay, where n is just a positive integer. Okay, so we can rewrite this very nicely. Okay, all right. We have, I've rewritten this in the form that I just, in other words, we're just doing exactly what I said a moment ago, rewriting each one to fit that form. Now let's go down to the next line. Now we take advantage of this identity here. You see the 1/3? Okay, this is very simple algebra right here to see that this equals this. You can find common denominator, you have a 3 in the numerator, divide by 3, and you get it back, right? Okay, so this is very easy. This is not hard right here. So what happens is that all of this becomes all of this, right? Based on, and I'm sorry I can't keep it on the same screen, based on that identity, based on this identity that you see right up here, this entire expression, which is equal to the original expression we're trying to evaluate, looks like this. And you may think, well, what have you done? But notice we've done something very pleasant here, because you have what they call a telescoping sequence. You have massive cancellation all the way through. Okay, all of these terms that I'm trying to indicate here cancel, right? Wow, isn't that cool? I mean, I think that's slick, all right? Now, I've heard of these before in calculus, but I never had really thought about it much just doing basic arithmetic, all right? So what you get right here is that this is equal to 1 minus 1/19. 1 minus 1/19 divided by 3. And to me, this is just marvelous. If you think about the work you'd have had to done at the very beginning without noticing this structure, okay, it would have been a nightmare. And it would have been error prone. Okay, so you have 18 over 19. You have 18 over 19 divided by 3, okay, which is equal to 6 over 19. Now, to me, that's absolutely astonishing that even though this seems like a lot of work, again, try doing it the old-fashioned way that they taught you back in middle school, and you'll see how much easier this is. So this is equal to 6 over 19. And again, if you were to, you know what I mean? Just look how large this least common denominator is. It does have a factor of 19 in it, so this is kind of a sanity check right here. But anyway, that's the answer. And we use this idea of a telescoping sequence or series, whatever, and just we took advantage of the structure of each of these terms. There's no common ratio or common difference or anything like this, so you have to look for some sort of algebraic structure that's common to each of the terms. We found that, and then you get this handy little easy to establish identity. You rewrite it, and you get all of this cancellation in the middle, and out pops a reduced fraction answer. Hope you enjoyed.